guys. Okay, so we're on our our third topic of this trimester, which is on inequalities. So we started with expressions. So it was like simplifying, distributive property, combining like terms. Then we went into solving equations. So simplifying and then getting x by itself and finding out the value of x. And then now we're going to be learning about inequalities, and eventually we'll be solving them just like we do equations. But today we're just talking about the basics, okay? So yes, this should be a review, but it's stuff that we got to really get down in our head. So first, let's talk about what an inequality is. There's a lot of vocabulary in math, right? So if you get confused, just kind of break down the word. You see the word equal in there. Equal is like equal sign. But if you put an in front of it, it's like un or non, meaning not equal. So symbols of inequalities are your little alligators, you know, elementary school, we talked about the alligator eats the bigger number. Those are inequalities, less than, greater than, but there's a little bit more than just less than and greater than. Let's start with those. So on your paper, you're going to draw a less than symbol. Now I get kids all the time going, I don't know which one that is, Miss Meineke. Is it this one or this one? Here's how you remember. Less starts with an L, so make an L, and then just tilt it. That's a less than symbol. So there you go. Okay, and then we're going to actually put its name right under it. So this is less than. Okay. Now there are some other names that go along with it. So I think we should like write it underneath. That is the less than symbol. But if you saw vocabulary like the word fewer, fewer means less than. If you saw maybe the word below, that means less than, lower than. Okay, you could even put lower on there too. All right, so let's talk about kind of the opposite of less than. Well, if you just switch that alligator mouth around, it would be like that, okay? And that is called greater than. So some words that go along with would be more. So there are more than, blah, blah, blah. Also above, like if you have to be above 5 feet to ride on a roller coaster or whatever, your height has to be greater than 5 feet. Okay, and we have some more. So we're gonna end up making a little chart. A little chart thingamabob. Okay, so here's our next symbol. It looks like the less than one. Okay, remember less than makes the L. That's how you remember that. But there's a little line underneath. It's kind of like half of an equal sign. So if you remember, this one's called less than or equal to. So that's its name. Less than or equal to. Less than or equal to. Okay, now here may be some new phrases that seem to kind of confuse kids sometimes when they read it. So let's make sense of this. So if you said there's no more than. So like in a sentence, if I said there's no more than 30 kids in my class. There's no more than 30. Could there be 25? Yeah. Could there be 31? No, because there's no more than 30. So you could say like 30 is your maximum. That's another word. Okay, so I play that game a lot when we do inequalities. If I say something is less than or equal to 30, I go, okay, could it be 28? Yes, because 28 is less than 30. Could it be 31? No, because it has to be less than or equal to 30. Could it be 30? And the answer is yes, because we said it's either got to be less than or equal to 30. Okay, so 30 would be a solution. And then another phrase you're going to see is the phrase at most. Okay, so there are no more than 30 kids in my class. Same thing as saying that there's a maximum of 30 students in my class. Same thing as saying I'm going to have 30 kids at most in my class. So all of those mean less than or equal to. The reason why I think kids don't kind of get twisted on these is you'll notice that it says more, most, right? So they think more, greater. But you got to put it in context. No more. It's not more. So it has to be less. Maximum is the highest amount. So it could be below that, but that's kind of that's your wall. You can't go past it. At most. That means at the most it can be. Okay. That's why that all falls into the lesser than or equal to category. So the opposite of less than or equal to would be greater than or equal to. So you draw a greater than symbol and then you put a line underneath. So that would be greater than or equal to. Okay. So I'm just going to kind of go from the opposite of this. The opposite of no more than is no less than. Opposite of maximum is minimum. And then instead of at most, it would be at least. Once again, you see words like less and least, so they think it's less. But no, this says no less than. So that's why it's your minimum. You can't go lower than that. It can be more or equal to. Okay, greater than or equal to. So maybe an idea for this would be like, to pass my class, you have to get no less than a 60%. So 60% would be the minimum percentage in order to pass, in order to get credit. So I could say you at least have to get a 60%. So if you got a 59%, would you be passing? No, because it's got to be greater than or equal to 60. Okay, so what if you had a 61%? Would you be passing? Yes. What if you had exactly 60? Yes, because I said greater than or equal to. Okay. Now, it might seem like there's no other possibilities, but technically we do want to include some other symbols in here, okay, that go along with this family. We got to talk about the equal sign, okay? That's just equal to. Okay. But a phrase that you might see is the word is. Okay. So if I said my nephew is 4, that would be X equals 4, or my nephew equals 4, right? So equal to, like the word is means equal. So if you see this in a word problem, you see this in a sentence, you can replace the word is with an equal sign, okay? And then what's the opposite of equal? Because these aren't actually opposites. The opposite, the straight up opposite of equal, and we have seen this in my class recently, if you put a slash through that, what do you say? Does not equal to. Or you can say not equal to or does not equal. Okay. So this might be is not or not equal, something like that. Okay, so those are the main symbols. You might need to refer back to this chart for things you're going to be doing today in the notes or on your homework or in class. All right. So we're going to be translating phrases into, like sentences, into mathematical statements, just like I did with my little nephew. My nephew Garrett is 4 years old. So we would say, you know, maybe G for Garrett. Garrett equals 4. Okay. So, but we're going to have a lot of these words in here, fewer, below, above, okay, whatever. So let's start out kind of more mathy though. We're going to use some math vocab here. Here you go. The sum, S-U-M, that's a math word. The sum of X and 5 is greater than 2. So that's your phrase. Now we're going to write it into a mathematical statement. So here are my suggestions. Whenever you see like a vocab word, circle it if you need to, but you need to remember what sum is. Sum means addition. So if you need to write addition right there, do it. So when I say the sum of X and 5, what are you doing with X and 5? You're adding them. So let's write X plus 5. So that's the sum of X and 5. But we have more information. We know that the sum of X and 5 is greater. That means more. Okay, so greater. Well, L is less, so it has to be this guy. Greater than, and it doesn't say or equal to, so we're not going to put the line underneath. It's just greater than 2. Boom, you're done. Okay, that's all we're doing here is we're making sure you can read a statement and put it into a mathematical statement. So read a phrase, put it in a mathematical statement. Okay, number 2. So I'm going to keep this trend of putting the statement on the right. The product of -4 and y is less than 10. The product of -4 and y is less than 10. And on all of these, I encourage you to try and write it first and then check it, right? Okay. So product, you have to know what that means. What's product? Product means multiply. Okay, product is answer to a multiplication problem. So the product of -4 and y, that'd be -4 times y. But in algebra and mathematics, we kind of make it a little bit more simpler. We don't necessarily need that multiplication dot. So -4 times y can be represented as -4y. That's the product of -4 and y. And then we go to this statement. This is your comparison statement. If it just said is 10, that would be equals 10, right? But it says it is less than. So think about your little trick. Which one's less than? It's the one that makes the L. So it's got to be this way. Less than. Okay. Here's number 3. The difference of 12 and a number, the difference of 12 and a number is greater than or equal to 20. Difference of 12 and a number is greater than or equal to 20. Okay, so your key vocab here is difference. All right, difference. Difference in mathematics means subtraction. All right, so the difference of 12 and a number. So when we say a number, maybe underline that. It didn't tell you what number. And in mathematics, if we don't know a number, what do we do to replace that unknown value? We use a variable, okay? So maybe point to that and write variable. So the difference of 12 and some number, so we don't know the number, let's call it n or x. Let's do x, we're used to x. So let's just do that part, difference of 12 and a number. So how this is written is you're just gonna kind of go in order of how it's stated. So the difference of 12 and a number would be like that, 12 minus x, okay? If it said 12 subtracted from a number, then that would be x minus 12. But how it's written is just the difference of 12 and a number. So 12 minus x is greater than, okay, so L is this one, so greater than must be this guy, but it says or equal to, so it's either greater or equal. So we put that little line underneath and then a 20. 12 minus x is greater than or equal to 20. Okay, next up, the quotient. The quotient of x and -5 is greater than 2. The quotient of x and -5 is greater than 2. Okay, so your fancy vocab in this one is this word right here, quotient. Well, if you just kind of look at what we have used, you're probably thinking maybe division, and that would be true. Quotient means division. Division. Okay, so I'm going to be dividing something here. The quotient of x and -5. So division. In my class, we don't really use the division symbol too much. What do we use for division? Fraction bar. So there is going to be a fraction bar in here. So the quotient of x and -5, that'd be x divided by -5, is greater than 2. Okay? So you will literally have homework questions like this. Hopefully they're pretty easy. But you're going to have some other kind of statements that aren't just straight up like that. Okay? So we got a few more to practice. Here's number 5. -8 is less than y. -8 is less than y. Okay, so if you just kind of go in order right here, -8 is less than y. Easy peasy. But I did this one on purpose because in mathematics, when we get to a final answer in algebra, do we want our variable on the left? No, we always want the variable out front. So we are going to rearrange this. So I'm going to do a little transition arrow. We're going to rewrite it. And it's not that this is wrong, it's just the proper way is to have your variable on the left, okay? That should be familiar to you. So here's the trick. You gotta just think about this. If I switch around the order and I put y on the left and -8 on the right, you gotta be careful with your symbol. So if -8 is less than y, then that means y is greater than -8. If you flip around the order, you also need to flip the sign. Kind of makes sense, right? If you flip around the order, if you flip around your left and right sides, you're also going to need to flip around the sign. Because if you think back to kindergarten or whatever, when your teacher said the alligator eats the bigger number, look, alligator's chomping towards the y here. It's got to still be chomping towards the y. That makes sense, okay? Another thing I always have my kids kind of do in class is finish the statement for me, okay? If Miss Meineke is older than her students, most of my students, right? If Ms. Meineke is older than her students, then her students are younger than Ms. Meineke. So if I switch around the order of how I say it, I also have to switch around that middle symbol, or in this case, older to younger. Okay, you have to flip it. Okay, number 6. 2 times the quantity x plus 5 is less than 14. 2 times the quantity x plus 5 is less than 14. Okay, whenever I see this word quantity, and some of you have maybe picked up on it in Zoom class, every once in a while I say quantity and then I have to catch myself because we really haven't talked about what that is. A quantity is just like a value, it's an amount, but more specifically when we have it kind of like this, when we see it in a statement, I immediately go like this, and I've even done that in Zoom, quantity, okay? So this is gonna end up looking like distributive property. Quantity means I'm gonna protect whatever group. So 2 times the quantity. Immediately I'm like, oh, it's like this. 2 times the quantity. So I'm grouping up something. What am I grouping up? I'm grouping up x plus 5. Okay, and then we look at the comparison statement, is less than, do your little trick if you need to, is less than 14. So that's that. Okay. Okay. A few more of these. And now we're going to go into more like real world examples. So here we go. There are fewer than 20 girls in this class. There are fewer than 20 girls in this class. Okay, so fewer, you can flip back to your chart. Fewer means less, right? So, but we need to know, is it going to be 20 is less than something or something less than 20? So here's what I would always say. Put your variable on the left. And in this case, it didn't really tell you what variable to use. Sometimes it'll be like, use G for girls or whatever, okay? But you can pick your variable. Let's just use G. Let's use G for girls. We know we're comparing it to the number 20. Now you got to pick your symbol, okay? The amount of girls, that's G. The amount of girls is what compared to 20? Well, there are fewer than 20, so the amount of girls is less than 20. That's it, okay? Number 8. You can use X if you want to, that's fine. Number 8, you can spend $20 at most. You can spend $20 at most. So maybe you went to the mall and your mom gave you 20 bucks and she said, this is the most you can spend. Well, okay, so what are we comparing? We know we're comparing it to 20 bucks, how much you can spend. So you could use S for spend if you want to. You could use X though, that's fine. I'm gonna use S. S is the amount of money I can spend. I'm always going to put my variable on the right and I'm comparing it to $20, okay? And you don't need the dollar sign because it's a mathematical statement. So you can spend $20 at most. Most people see most and they think more and they put greater. But you need to really think about this. If you only have $20 with you, can you spend $25? No, because if you put a statement like this, it'd be the amount you can spend is more, is greater than 20. That's not true. I have to be below 20, right? Okay, so I can spend lower than 20. So it's fine if I only spend, 10 bucks, 18 bucks, that's fine. But 20 is your maximum. So now you get into questioning yourself, Can I spend exactly 20? If 20 is the most I can spend, can I spend exactly 20? The answer would be yes. So 20 is your maximum. S, how much you can spend, is less than or equal to 20. Okay? Okay, so we're going to call that good. And now we're going to get into graphing. Graphing inequalities. Okay, so graphing. Here's our first graphing problem. So here's your inequality. X is less than 5. X is less than 5. All right. So we're going to be graphing on a number line. So that's not an XY yet. We're not there. We're just on just a number line. So here's how I would recommend graphing. I always put whatever number we're questioning, I always put that in the middle. You don't have to, it doesn't have to be in the middle, but when I'm making my own number lines by hand, I just put that number in the middle. I want to see at least 2 values to the left, 2 values to the right. Now, your little number spaces should be pretty equally, the little tick marks should be pretty equally spaced. But you can count by 1s, you can count by 2s, you can count by 5s. Doesn't really matter. So if I wanted to count by 5s, I totally could. If you want to count by 1s and do 6, 7, and 4, 3, that's totally fine. Okay? But how do you graph this? X is less than 5. Think about all the numbers less than 5. So right now, tell me a number less than 5. 4. Okay, 4 is like right here. What else is less than 5? 0. What else is less than 5? Negative 1. 2. Negative 5 is less than 5. Negative 20, which would be, over there, whatever. That's less than 5. So all of these numbers are which direction from 5? Just to the left. So here's what we're going to do. It's going to be an arrow going this way. Okay? But there's got to be some sort of symbol at 5. And we put a circle. We put a circle at 5. Now, notice I kept it open. And that's important. Do not shade it in yet. Okay? There is a difference between a shaded in circle and an open circle. And you're going to make yourself a little chart right here. An open circle versus a closed circle. When you would use an open circle is if something is strictly less or strictly greater. Okay? When you would use a closed circle is if it was less than or equal or greater than or equal. Okay? And I'll try to make some sense to that here in a bit. So these go together, these go together. So if you look at your symbol, we can look up here at our little chart and say, oh, that's an open circle. Here's why. Open at 5 means it can't equal 5. 5 is not less than 5. Okay? Right? 5 is not less than 5. 5 is 5. So 5 cannot be a solution for x. 5 is not a correct answer for x. But 4 is less than 5, 3 is less than 5, so 4 could be a solution, 3 could be a solution, negative 5 could be a solution. You have a lot of solutions here, but it has to be to the left of 5. Okay, so we would say open circle at 5, pointing to the left. Here's number 2. Number 2, x is greater than or equal to negative 1. Okay, so I'm going to start with negative 1. I'm going to put that in the middle. You don't have to, but that's what I do. Give me 2 values to the right, 2 values to the left. You can count by 1s, 2s, whatever. I'm going to count by 1s in this case. So to the right would be 0 and then positive 1. To the left of negative 1 would be negative 2, negative 3. Pause the video if I'm doing that too fast. And then when we go to graph it, here's what I kind of start doing. I look at this symbol and go, okay, is that open or closed? In this case, it's closed. So we're going to have a closed circle at negative 1. Now we got to read that correctly. Is that less than or greater? Use your little L trick. That one was less, so this one's greater. So x is greater than or equal to -1. The fact that we shaded it in takes care of the or equal part. So -1 is a solution. But where are the other numbers greater than -1? Greater is always going to be to the right because that's where the positive numbers live. That's where the bigger numbers live. So you're just going to simply point this to the right. Okay. Here's number 3. I suggest you do it. Number 3 we'll talk about, okay? 5 is less than x. Okay. The reason why I did this is because, ew, your variable is not on the left. I would recommend flipping it around because let me show you a big fat mistake that some kids do. So they put 5 in the middle and they go, okay, here's 10, here's 15, here's 0, here's -5. Okay. And then they're like, okay, that's going to be an open circle according to this chart. So it's not equal to, it's just open at 5. And then they see this less and they want to go to the left. But that's actually going to be wrong because x is not less than 5. 5 is less than x. So let's rewrite this so we can graph it properly. If 5 is less than x, then that means that x is greater than 5. Okay? Because x is your possible solution. So your possible solutions are greater than 5. Well, where do the numbers live that are greater than 5? To the right. Okay? Okay. Couple more things I want to graph. X equals -4. So I'm going to put -4 in the middle. Do your little tick marks. I'm going to count by 2s on here. You can count by 1s. It's totally fine. Okay? You just got to be counting by the same thing the whole way. Okay, so equals. Equals. X equals -4. Now, in all of these little arrow things, the arrows are pointing to your solution set, to your solution area, whatever you want to call it. So anything in this direction is a solution for this problem. Anything in this direction is a solution for this problem. But that just says equals. X is -4. So if x equals -4, can it be anything else but -4? No, this only has one solution. These have many solutions, okay? Not infinite, but they have many. Whereas this is an equal sign. So the only thing it can be is 4. Now, am I going to leave it open or shade it in? I'm going to shade it in because it equals -4. Okay. Would there be an arrow? No, because the only solution for x is -4. Okay, and number 5. Number 5, you have x is not equal to 8. X is not equal to 8. So I'm going to put 8 in the middle. I'm just going to count by 1s this time. You can count by whatever you want to count by. All right, I look at this symbol, does not equal. X does not equal 8. It can't be 8. Well, if it can't be 8, basically what that means is it's anything but 8. So your solution could be 7 because 7 does not equal 8. It could be 6 because 6 does not equal 8. It could be 9, it could be 10 because 9 and 10 do not equal 8. So any of those numbers would work except for what number? 8. So you would put an open circle at 8 because it does not equal 8. But anything besides 8 would be a solution. So that'd be how that works. Okay? Now, you are literally going to have one practice problem to do. And it's going to be a statement like this. Are you ready? This is your one practice for your entry task. You must be at least 60 inches tall to ride the roller coaster. You must be at least 60 inches tall to ride the roller coaster. Now, because we're going to put this into our entry task, let's go ahead. I'm going to set you up with your variable. Let's just use X in this case, and we know we're comparing it to 60. So really, your only thing I want you to do is figure out what symbol goes there. That's it. Okay? Thanks for watching. See you guys in class. Okay.